So today we're going to be looking at the construction of the Mohr circle, and the reason for doing that is to look at the shear envelopes to predict the mode of failure of various soils. If we look at example 4.2, to give us an idea of how to construct this Mohr circle diagram, we are given in example 4.2 the value of the minor principal stress, sigma 3, and the major principal stress, sigma 1, which will mean the lower and the higher end of the semicircle in this case. We first calculate the average, which will be the centre point of that circle. So the centre of the circle will be given by the sigma bar value. So in order to construct this, we first estimate how much space we need on our graph. So the highest value is 1162, so we need to go to about 1200 on the horizontal scale in order to be able to fit it. The vertical scale tends to be about half of that because, as you can imagine, in a circle, the diameter is twice as big as the radius. So let's look at the first two readings. So for a value of 200 confining pressure, which is a sigma 3, the principal stress at which the soil failed at was 570. So we're going to put the centre of the circle at 385. Now, please be aware that because I'm doing it on the whiteboard with very rudimentary devices, the results won't be as good as you doing it on your books or in CAD for that matter. So 385, that's 350, that's 400, so 385 I'm estimating to be about here. The lower value is 200, so stretch my compass to the 200 value. I just need to lengthen the pen a little bit. Okay, let's try again. So the pointy bit sticks here, the pen bit sticks on the 200, and with a very relaxed hand, I am going to move. Okay, not too bad. That's looks like about 560. So I missed the spot by a bit, but good enough. 300. And 875. The median value, which is the centre of the circle, is at 587. 587 will be approximately here, and the lower end has to go down to 300. So I'm going to open up my compass, tighten it up afterwards, of course, so it doesn't swivel, and place the centre, which is your pointy bit of your compass. If you're sorry, it got away from me. I did this 1 year, I did this 1 year and got the result perfectly matching the book, but that was a rare occasion. Comets only come to Earth once in a while, and that must have been a comet landing on that day. 781 is the centre, 400 is the lower value, so 700, 750, 800, 781 will be a little bit underneath. Once again, I'm just eyeballing it, it's not measured precisely, and the lower end has to be 400. So I place the compass here and draw my circle, trying to take care not to wobble it. Okay, so they are the three failure envelopes. I need to, sorry, they're the three, they're the failure modes for the three values of sigma 1 and sigma 3. If I want to find the failure envelope, I need to do a tangent of best fit to all of those semicircles. Now, if you did this correctly, you would find that that tangent will match and meet all semicircles. In reality, with real soils, it will never be perfect because, once again, this is a theoretical approximation of how a real soil behaves. So I'm going to attempt to do a line of best fit, or a tangent of best fit, and lo and behold, I find that the tangent best fit actually goes through 0, 0. Now, it's not always going to go through 0, 0 because if you have any clay content, you have some cohesion. The y-intercept will be at some value on that y-axis. In this case, because you have a clean, cohesionless soil, there is no tor value or tough, and it goes through 0, 0. Okay, so we've got what we call a phi soil. Phi soil. Now, in order to work out phi, the angle phi, it's not theta, let me, and I've misplaced, and I haven't, it's here. In order to work out phi, there's a variety of techniques, but the easiest one, rather than doing too much complicated mathematics, is to find a value on the horizontal axis that is pretty well defined. So randomly, let's say it's going to be 500. So that value I know precisely. I'll go up to here and project across, making sure that your ruler is horizontal, otherwise you could be out by quite a bit, and find that the y-intercept, in other words, I'm trying to work out the slope of the line. So x is 500, y is approximately, let's say it's 265. So phi is the inverse tan of 265 over 500, and I'm not sure exactly what it is, but if I did this correctly, according to the notes, that should give you about 29 degrees. Okay, so in your case, your graphs will be a little bit more precise, but that's basically the procedure. The important thing to note is that you need to construct the centre of the circle in order to know where you're going to put the pointy part of your compass, and to try to always project with a ruler rather than just eyeballing.